Thanks, Pravalika, Alexandra, Mahesh. So, hi everyone. Thank you for joining this meetup. Kishore, can I go ahead and share, or will you be sharing?
Oh yeah, please. I have stopped sharing. You can take it over, please.
Okay. I just I hope my internet. It's been having issues from the morning. So first, let me just introduce myself. My name is Lakshmi. I'm part of the customer success strategy and architecture team at MuleSoft. So it's another division, like Kishore is part of the professional services. I'm part of the CSSA team, customer success strategy and architecture. So we work with customers across US and Canada, all the major customers, to provide them strategic and technical guidance on how best to utilize the platform, how to scale with the platform, how to onboard more use cases effectively, and basically how to be successful in the long run, how to leverage the capabilities to be successful in the long run. I have around 14 years of experience in various integration platforms, not just MuleSoft, and I've been in consulting roles before I joined MuleSoft. So thank you all. I'm based out of Toronto, and thank you for joining this meetup. So I'll go ahead and share my screen. Just give me a minute. Please let me know if you can see my screen.
We can see your screen.
Okay, cool. So I wanted to talk about, in general, I'll start off with testing strategies that, the important testing strategies that apply to Mule applications. I'll talk about MUnit, and also I wanted to show a quick demo of the MUnit test recorder, just to show how easy it is to automate your test creation process. And because, writing MUnit test cases is easy, but it's even more easy if you can just automate it. If 80% of the work is automated, it will help with developer productivity, and it will help your in your SDLC process. It will help you save time. It's a really cool feature, and it is very it doesn't solve all your problems. It is still evolving, but at least certain use cases, straightforward use cases, wherever you can use it, you should use it instead of writing the test cases from the scratch. So let's look at it in the end. I'll show. This is the agenda that I wanted to cover today. So the types of testing mainly applicable to Mule applications. We'll talk about unit testing, integration performance. Then what is MUnit? Where does it fit into? What are the test scopes? Why MUnit? What are the tools that MUnit provides? What can you do with those tools? And then we'll look into the test recorder and a demo. So starting off, so the importance of testing, we all know how important testing is. You need proper testing strategies before you deploy your code to production, and after you deploy code to production, to make sure that your code is performant and reliable. At every stage of your SDLC process, you should have appropriate testing methodologies to make sure that the code being promoted to higher environments is, properly tested, and you're making sure that all the pieces work together separately as well as work together. So it's with everybody knows the importance of testing. And when you look at the types of testing that are applicable to Mule applications, the first one is unit testing. So unit testing is like it's considered a form of white box testing, where you must know the internal workings of the code to be able to generate the unit test cases. It is usually, unit test cases are written by developers because they understand the internal workings of the application, and it is primarily focused on testing the components within your code, the individual components within your code. In our case, either a Mule application, in the Mule application, within a flow, within a subflow, whatever components you're using. Our goal here is to test each and every component within a Mule application. So that is the whole purpose of unit testing, and it does not worry about external dependencies. It is only worried about what the Mule application does and what are the components used within the Mule application. When we pass our unit test cases, we then move on to integration testing. And since integration layer will be talking to many different systems, right? The source system, the calling application, the backend applications, the databases that we talk to. We might be making HTTP calls to other sources. So the end-to-end testing. So this is more like of a black box testing where you're only worried about the request that is passed to your Mule applications and the response that is received after it talks to those backend systems, and whatever response is received, you're making sure that request and response are as expected, and all the interacting systems are functioning as expected. So you need to have a little bit of technical knowledge, but you don't have to know the internal workings of the code. So we make sure we do integration testing. Once we complete our unit testing and move it to a higher environment, we can do integration testing to make sure that once we integrate with all the other systems, everything is working as expected. And then performance testing is very, very useful, important. So you must make sure that the code that you are deploying to production is able to scale under heavy workloads, is reliable. It can perform when you take, for example, if you have real-time use cases, and if you have stringent SLAs on performance, if the response time should be within a certain millisecond, you have to make sure that you do the appropriate load testing and the stress testing to make sure that those SLAs are not compromised under any circumstance. Similarly, if you have a lot of asynchronous processing, if you're publishing to queues and topics, if you're doing a lot of working with a lot of messages, then you have to make sure that reliability is very important. You don't have any message loss in any scenario. So those that is also tested as part of your performance testing. So you do all this load test, stress test to make sure that the system does not crash at any point of time, and you're making your solution more reliable before you deploy to production. So performance testing, as we all know, is extremely important and is usually done in an environment that mirrors production, so that you have the same infrastructure. When I mean infrastructure, the same, the CPU, memory, the OS, everything is the same. It mirrors production, and you try to, create an environment where you get traffic similar to what you will get in production, and see how the code, it performs before you deploy to production, so that you get that peace of mind. So looking into unit testing, like I said, unit testing is testing the individual units of code within your Mule application. So every small testable part of your Mule application has to be tested. Apart from unit testing, you will only in this phase you will test each and every component of your Mule application. As you go to higher environments, you're not nobody is going to be worried about what exactly. When you might have a for loop, you might do an if else, whatever it is. Nobody is going to be worried about each and every condition within your Mule application. So it is extremely important that you have executed unit test cases, and they are successfully executed before you deploy to higher environments. And these unit test cases should be generated for each and every condition within your Mule application. So every small component which can be tested should be tested in your unit testing phase. Like I said, this is typically done by developers as they are developing the code. And the goal here is to find problems early in the development cycle, fix them quickly. You want to automate the execution of these test cases. I'll show you simple with Maven, right? Everything is Mavenized in Mule, so you can kick it off from your CI/CD process. But the goal here is to have these automated test cases executed every time you check in your code, so that you have a peace of mind that whatever, you might have different teams working on the same code base, and you know that somebody's change did not break somebody else's functionality. So you have these test cases automatically executed every time you check in the code, and you know that the code is working as expected before you deploy to QA and go ahead with the other testing. Integration testing is usually done after unit testing, where it combines with other systems to make sure that when you integrate your integration layer with other front end and backend systems, they are all working as expected. The database calls, the HTTP calls that you make, the final response that is returned from the Mule application is what is expected, and the front end system is able to, for example, display the data in the way that it was meant to. So just making sure that end-to-end testing is successful. Performance testing, again, just reiterating what I said, when you do when you start with your projects in the design phase, you must come up with non-functional requirements like what should the response time be? If you have some synchronous transactions, what should the response time be? What will be the payload size be? Is it heavy payload sizes? In that case, your memory could be something that you have to look into, because the payload will be loaded into the memory. So you must know if you have properly sized your Mule applications, if you have allocated appropriate vCores. Each vCore has fixed CPU and memory. So how do you know that you're properly sized your Mule applications? Only if you do performance testing, you will know that. So how many requests? Similarly, if the number of concurrent requests that a Mule application can process at any point of time, that is also dependent on the vCore that you assign to the Mule application, because the Mule runtime will spawn a certain number of threads based on the number of vCores that you assign to the Mule application. So is that enough, or do you have to do some tuning around it to understand if you have a CPU issue or a memory issue? Is there if you're doing a test for 2 hours, is there a specific point in time where you see a spike in usage? Why is that? To understand all of this, you need to do performance testing and parallelly look at the metrics in, we have anypoint monitoring. You can look at the dashboards in anypoint monitoring and understand how the usage is, how the requests are being processed. Is the system stable for the entire period of time, or do you see hung threads? Do you see or do you see CPU issues? Do you see memory leaks? You'll find all this out during your performance testing phase. So it is very, very important to make sure that even after you deploy, the code is in production and is being used by your consumers, that it will be able to handle any seasonal traffic, any increase in traffic, and at any point of time. Yeah, so I have 3 trivia questions. I just split them out across the presentation. So is it okay if I go with the first question? Do you want to say anything?
Yeah, please go ahead.
Yeah.
Okay, so this will be the first question. What type of testing is focused on testing every component and does not test any external dependencies?
You can tell the answer now.
Yeah, you can tell the answer now. Yeah, that's fine.
Yeah, the correct answer is unit testing. Like we discussed, we do not worry about the external dependencies, and we are only focused on testing every single component within the Mule application, which is a flow or a subflow or any processor that you use within the Mule application. So what is MUnit? Okay, so we talked about unit testing. Now let's talk about how we create unit test cases for Mule applications. So MUnit is MuleSoft's in-house application testing framework. So it is very easy to write MUnit test cases because it uses the same IDE that we see, the Anypoint Studio, and it is very similar to creating Mule applications. It uses the embedded Mule runtime to execute the test cases, and it is fully integrated with Studio and with Maven. So it's an important step of your CI/CD process, like I said, is to automate the execution of your test cases. And basically, whenever you check in the code, you should be able to trigger the Maven commands, which will execute your MUnit test cases and give you the output, right? So MUnit is fully integrated with Maven for CI/CD, and it is like the recommended way to test your Mule applications. It has a lot of tools that does a lot of things like mocking, spying, verifying that a component was executed a certain number of times. We'll go through all of that, but this is high level what is MUnit. And like I said, why you should be using MUnit? Because it's very, very similar. It's easy to use. You're using the same Studio IDE, and it is Mavenized by default. So it's like basically developing a Mule application. It is very similar to that. You'll be using the Mule palette, and you'll have MUnit tools within the Mule palette to create your MUnit test cases. And it can create coverage. After the test cases are executed, it creates coverage reports automatically. It checks the code coverage, how much code coverage is handled within the Mule application. And you have configuration in the pom.xml. You have a section for configuring the Mule Maven plugin, where you can specify a lot of parameters. I'll go through them during the demo for your when you execute them through Maven in your CI/CD process. So it is very easy to configure those. It's just configuring in the pom.xml, and like I said, it is the native framework for testing Mule applications. So when you look at the test, when you look at an MUnit test suite, so when we create a test suite for a Mule application, this is how it will look. You will have 3 sections. You'll have the behavior, execution, validation. Like like I told you, right? You have tools to do mocks and spies, and you have you can do assertions. I'll go through each of them in detail, but this is where they will sit. So all your mocks and spies will sit here. The actual execution of the test case will be here. You'll have the flow reference over here, and you'll have all the assertions and verifications, like when you assert that a particular value it is equal to a specific value, or you verify that a particular component is executed only a specific number. Those validation will go over here. So this is how the structure of a test suite is. And the tools, like I said, if you look at the tools, the most important tools that you'll be using when you create your test cases are these. The first one is mock. So like I told you, right, when you create a unit test case, you should not let any external dependency, whether it's a database or a HTTP call or any external call that you're making, you should not let your external systems affect the execution of your test cases, unit test cases. So for that, you need to mock out those external dependencies. So that's why you'll use these this mock tool, where you can use this mock tool to mock an event processor when it matches a specified value. So you can actually have a data v file that will. So take, for example, you're making a post request, HTTP request to an external service. You can mock that call, and you can create a data v file that will have the payload with the mocked payload. So that in your test case, the test case will refer to the data v file and will validate it against the mocked payload in the data v file, and will not actually make the external call. So you can do that so that you don't have any external dependencies. You're mocking out that external dependency. We can also mock errors. I will talk into that. I'll talk about negative cases and how we can mock that as well. But mock is useful to do negative testing as well. Assertions, assertions are like you have 3 types of assertions, but basically to Boolean check that a value is a specific value is such and such after a particular execution, or after a particular component is executed. If the value is equal to a specific value or not, you are asserting that you're doing that validation. Spy is you can spy on a component. You can spy on the Mule event before and after the execution of a component. So take, for example, if you're doing a transformation, you can spy before and after the transformation, and you can do an assertion within the spy to check if the value of the Mule event is correct before the transformation, and if the value is what is expected after the transformation. So basically, you're spying on components to make sure that the Mule event, whatever transformation has taken place or not. This is just an example transformation. You can spy on any other component, but basically to spy on flow components, you have a MUnit test tool. And finally, verify call, making sure that a particular event processor is called only the specific number of times. Like if you have an infinite loop and it keeps on calling, you can have this verify call and basically you can say that a particular processor should be called only a certain number of times, whether it's 1 time, 2 times, 3 times, depending on whatever the logic is. And if it does not match that, it will throw the test case will fail. So you're verifying that a processor was called the required number of times. I'll show this in the demo. It's much more easier, but this is just how the mock will look. And this verify call, like I told you, you can specify how many times a particular component should be called. And spy, again, you can spy on a particular component. I'll show you examples. And with regards to assertions, like I told you, there are different types of assertions that you can do. So we have 3 things. This is important. Assert that, assert expression, and assert equals. So assert that is, allows you to run assertions. It uses a set of inbuilt data v functions. MUnit provides a set of data v functions called MUnit matches, and you can use those inbuilt data v functions to do the assertions. I'll show you the data. This is the inbuilt data v functions. It's called MUnit matches. This you can use within assert that, not within these 2. Within assert that, you can use this inbuilt data v functions called MUnit matches. And these are a set of data v functions that MUnit provides, where you can do string comparison. You can do, you can check if if the value of string is this, if the length of the string is this, you can do all sorts of comparison. You can do iterations. You can do you can check if the value is bigger than that, smaller than that. Basically, inbuilt functions that the Studio you can use these inbuilt functions that MUnit provides to do comparisons. Assert expression, it allows you to evaluate a data view expressions, and that data view expression will assert the state of the Mule event. So basically, whatever assertion that you do, you can have it externalized at a data view file, and you can use something called the data view assertions library to write. This is for complex assertions. When you have cases where these inbuilt functions don't help you out, and you need to do some more complex assertion, you can externalize it in a data view file, use the data view assertions library. I'll show you. The MUnit test recorder will actually use the assert expression, and it will create those data view expressions automatically. So you can have those assertions externalized in a data view file, and you call it using the assert expression. So assert that uses the inbuilt functions called MUnit matches, and it has certain inbuilt functions, data view functions that is automatically provided out of the box to do the comparison. This one evaluates it using a data view expression, and it internally uses a data view assertions library. So you can have all your assertions in separate data view files. You do complex assertions using the library, and basically call that data view file in your MUnit test case using assert expression. And the last one is assert equals, which is for simple comparisons, like if it is equal to a specific value, the payload is equal to a specific value. Straightforward, simple comparison, you can use assert equals. But mostly you'll be using assert that and assert expressions, depending on whatever the use cases. So we saw about MUnit matches, and then negative testing scenarios. So it's very important. It's very important that you not only test the positive cases, you should also have test cases that do negative testing. So if you encounter an error in any part of your code, and if you, for example, you're doing error handling, how do you know that the error handling logic executes as expected, and it gracefully handles the error? How are you making sure that code is executing as expected, and it gives the custom error message and doesn't throw a blank 500 error or 400 error or whatever it is? So you have to make sure that you create test cases, and I'll show you how easy it is with using the mock tool that we discussed about. You can mock the error itself and make sure that error is returned, and that test case, you can create a negative test case to make sure that the error is gracefully handled, and the end user will only get the actual error message that he should see. So it's very important to create negative test cases as well. So we'll look at that as well in the demo. And just some best practices for writing unit test cases. So make sure that they are they are targeted. So the ideal unit test case is one for each message. Like I told you, every single component should be tested. So ideally, every subflow should be tested. You always test all possible paths. If you have a condition, if else, or whatever it is, make sure that every condition has a test case, so that if a value is equal to this, if a value is equal to this, you can make sure that those conditions are all executed, and they have test cases to make sure all those executions are successful. Like I told you, mock out all your external dependencies. Your unit test cases should be isolated. We are only concerned about testing the components within the code. So external dependencies, don't let your external systems affect the execution. It should be repeatable and predictable. The whole point of writing these test cases is to automate them, right? So they can be tested out over and over again. So you should have the test cases in a way that test itself, it should produce the same result. It should be capable of running it over and over again without having different results every single time. So it should be repeatable and predictable, and it should be independent. You should try to have test cases in such a way that one test case execution or output should not control the execution of another test cases. Try to make it independent, because if it is dependent on one another, it will be very hard to debug and maintain. there should not be a restriction that your test cases should run only in a specific order. It's better if they are all independent. And of course, please keep it readable so that anybody in different teams, they are able to understand what the test case does. We have sections to give clear descriptions and name and description to the test case when we create the test cases. So give a meaningful name and add the appropriate description on top of each test case. You can also, I'll show you that you can tag your test cases. Basically, you're categorizing your test cases. You can categorize positive test cases, negative test cases. You can execute only the positive test cases and not the negative test cases. You can do all of that. So there are configurations to do all of that. Okay, trivia question 2. So I'll go ahead with it. Which MUnit tool's assert event processor uses a set of data functions to define the assertion conditions for any value in the expression? Assert that, assert expressions, or assert equals? Yeah. Correct answer is assert that. So like I said, it uses the inbuilt MUnit matches, the set of data functions called MUnit matches to do the assertions. So answer is assert that, A.
Yeah, Pawan Kumar,
I think
please
it's
ping me
Pawan Kumar.
yeah, please ping me your email address. Thank you.
Okay. All right, so let's get into the MUnit test recorder. So we spoke about MUnit. Basically, we look into, again, whatever we spoke, I'll show you examples. But basically, the test recorder will automate the test case, the MUnit test case creation. So before this, you had to...
Sorry to interrupt. Before we lose this question right in the messages, I just wanted to let you know that we have a question from Pratyush Mahopatra. And his question is, what is the difference in isolated and independent?
So isolated from the context of the external dependencies. So what I meant was, if you're making external calls like HTTP calls, database calls, try to stub out those external dependencies using mock so that your test case is isolated. It is not affected by any other external dependency. And independent was, if you have 3 test cases, one test case execution you should not have a scenario where one test case execution should only if it is successful, the second test case can be executed. There should not be that restriction because that will be difficult to maintain. If each test case can be independently executed, and if they can independently produce results, that's the ideal state where we want. So if you have 3-4 test cases, keep them independent, and isolated is don't have any external dependencies. Stub out all your external dependencies. Is that okay? Sorry, I can't see the screen, Pravalika. So tell me if I can proceed.
Yeah, actually, there is another question. So I guess it's clear to Pratyush. And Harneet Kochar has a question. So can you please explain answer for trivia question 2 again? I just wanted to understand.
Sure. Yeah, let me go back. So I told you there are 3 ways to do the assertions. So I'll show you this, but this is what in the MUnit tools, you have mock, spy, verify call, and you have assert as well. And within assert, there are 3 ways to do the assertion. So what are we doing in assertions? You're validating the state of the Mule event. So basically, you're checking after a particular processing is done, whether the value is equal to this or value is equal to that. You're validating that state. The way you do that validation, there are 3 things that you can do, 3 ways to do it. Assert that, assert expression, and assert equals. So assert that, when you use assert that, you have the option to use a set of inbuilt data function called MUnit matches. So these are inbuilt functions that MUnit provides. So I'll show you in Studio, you can look at all the inbuilt functions. So if you want to do string comparison, dot equals ignore case, this string is equal to this string, or what is the length of the string, all those inbuilt functions are already available to you, and those are called MUnit matches. If you want to use that, you have to do assert that. And that was my question, like which out of these 3 uses the data function to do the assertion and do the comparison between the values of the Mule event. The other 2 don't use this data functions. Assert expression will actually use the data weave, will do the assertion in data weave and use the data weave assertions library, which you can use to do complex assertions. It doesn't use this data weave function. And this is for straightforward, just checking if a value is equal to 1 or 2, or if its value is equal to A or B, like that, straightforward this thing, comparison. This assert that, if I show you, maybe it'll be even more clearer, but this assert that is what will use this inbuilt data weave function. And that was my question. Is that okay?
Yes. So I think she's clear now. Thank
Okay.
you, Lakshmi, for the explanation.
Thank you. Yep. All right. So MUnit test recorder. So before this test recorder was released, the option you had was to create a blank test suite and then start creating the test cases from the scratch. But here you can automate that creation of those test cases. Basically, I'll show you how it is, but it captures. So when you invoke a particular Mule application, so take, for example, you have an HTTP listener and you're making a call from whatever, Postman or whatever, you're making the call, you're invoking that Mule application. It will capture the entire flow of that Mule application. It will record it, and then it will create the test case automatically. All we need to do is configure what we want to see in that test case. So that's this thing. So you don't have to from the scratch configure everything. This will increase the speed in which you create your test cases. It's a way to automate your test case creation. So I'll show you. So let's go into the demo. And to use this test recorder, you need minimum. It is compatible with Mule Runtime 4.3 and Studio 7.5. That is a prerequisite. Yeah, it is. It was a recent release. I mean, not recent. It came last year, I believe. So it's compatible with those. So you can see my screen, right? The Studio. Just confirming.
Yes, you can.
Okay. Okay. So I have a simple Mule application. So it has a HTTP listener, which receives account ID as a URI parameter. I'm setting it to a variable. I'm calling two flows. The first flow is a very simple Mule app. So the first flow, what it does for this account ID, it connects to a database. It does a select. It does some transformation, and then this second flow, whatever I receive from the database and the transformed result, I am using that data to create a record in Salesforce. So I'm connecting to Salesforce and I'm creating a record. So simple flow. So this Mule application, it gets input, an account ID as the input. It calls a database with that account ID, fetches the details, does some transformation, and the second flow, whatever the transformed output is there, it uses that to create a record in Salesforce, and that's it. So the final output is to create a record in Salesforce. So, and this is a simple Mule application. Now I want to create test cases for this Mule application using the test recorder. So before I start with that, I wanted to touch on this. The form.xml is extremely important. So the first step you'll do when you want to use MUnit is you go here and just configure MUnit name and support. So what it will do is it will add the dependencies for your MUnit execution. So if you go here, you'll have two dependencies that are added. One is so these two.
Is it possible for you to zoom into your screen a bit?
I just did some more zooming for the form.xml. That is okay, right?
Yeah.
This is fine. Yeah.
Okay. Do some more. Okay. So basically, when you sorry about that, but we'll see. When I create when you use the test recorder, it will mostly be pop-ups. So I think it should be clearer. Please tell me if it's not. We'll do something about it. So the first thing you do is configure MUnit support. So when you do that, these two dependencies will be added, the MUnit runner and MUnit tools. And this is what you'll see in the Mule palette. The tools will be there, which will have the mock, spice, assertions, and you need that to create your MUnit test cases, right? So you do this part, you add this MUnit support, and you will also see this section, this this plugin section. which is the MUnit Maven plugin. This is very, very important, this section. You'll find that you'll have a lot of configuration over here within this plugin. So this will give you options to configure, and all this applies. This section applies when you execute your test cases from your CI/CD server using your Maven commands. So this doesn't apply when you execute it in Studio as it is. That you can just configure that directly and run the test cases in Studio. But when you execute your test cases from Maven, this section is very important. So this configuration section, it has a lot of configuration around, if you want to specify code coverage, you can specify, you have 3 different types of code coverage: application code coverage, resource code coverage. We have one more, if I'm not wrong, property code coverage. You can application resource flow code coverage. You can specify what you need, how much code coverage should be specified. You can specify the percentage. Should it be 75%, 80%, 90%? And you can fail your test case if that code coverage percentage is not reached. So you can specify all of that over here. You can specify run coverage equal to 2, and you can add tags over here to specify the code coverage percentage and what code coverage should be covered. This is the format of the final output of the test case. Should it be in HTML, console, JSON? We also introduce support for SonarQube. If you're using SonarQube in your organization and you want the output in a way that is compatible with SonarQube, you can specify the format here as well. You can specify if you want to redirect the test output to a different file other than the default location. You can specify that, you can specify true over here, and you can give the location path also over here. And then there are plenty. You can ignore a particular flow if you have multiple flows in your Mule application and you don't want the test case for one flow to be executed. You can ignore flows. You can specify ignore flows, the tag ignore flows here, and you can specify the flows to ignore the, which they have to be ignored. You can do that as well. So there's like plenty of configuration you can do, and there is documentation around each and everything depending on what you need for your use case. But remember, this section, this plugin, the MUnit and Maven plugin, is applicable when you execute your test cases through Maven. And this is the way you control all the different, you'll have different requirements based on your organization needs. So here is where you will do the configuration to control all of them. Okay. So next, coming back to this now. So now I have, is this okay, Pravalika? Like, is it still the same? I mean, at least.
No, actually, this is very small. Like maybe the participants can zoom into their screens. Yeah.
Okay. Yeah, I mean, but simple. Just to reiterate, we have HTTP listener. We have 2 flows. First flow calls the database with the account ID is passed to the HTTP listener as a URI parameter. It uses the account ID to call the database, and then second does transformation. And the second flow will use the transform output to connect to Salesforce and create a record in Salesforce. So that we have like one main flow and two private flows. And now we need to create test cases for this. So like I told you, we want to create test cases for each and every component in each and every flow, right? So I start off with, take for example, this flow. This connects to the database. So what I will do, when I go to MUnit, I'll have 2 options here. Can you see this? One is the create blank test for this flow, and the second is record test for this flow. So before this MUnit test recorder was not there, you will have only create blank test for the flow. But now I have the second option, record test for this flow. So when I click on this, what it will do, it will launch the embedded Mule runtime. If you see here, it is using the embedded Mule runtime. It is going to start up the application. And then you will see a pop-up come up.
So Lakshmi, after this, we have a couple of questions. So once you have some time, maybe we can stop for a minute.
Yeah, sure. Yeah. It should come up now. So I'll just finish it and then take that up.
Sure.
So yeah, so you have the pop-up for the test recorder, if you see. And so now what it is doing is it is waiting for input data. So now I'm just going to invoke this Mule application. So you can use Postman or Advanced REST client, whichever is. Okay. Okay, so what I did, I invoked the flow. Now, if you see, it did the recording. It was recording, and the recording has stopped. So it has completed the entire recording of the flow. And now I can go ahead and configure the test. So when I click on configure the test, the first thing that you see is the test suite name. So this test suite will have all the individual test cases. So we have 3 flows. So there will be 3 test cases for each flow, and they will all be sitting in one test suite, which is this test suite name. Okay, so retrieve account details, which is the flow that connects to the database. That is what I'm creating the test case now for that flow. So that is the test case name. And then now if you see, I have these things, right? So I can configure. If you see, I had passed. So for the main flow, I would have passed the customer account ID as the URI parameter, right? So I passed the URI parameter as if you see here, I passed it as 16. So in the flow input, if you look at inside the URI parameters, I have account ID as 16. Okay, so that is all captured, and it is setting the variable to a variable account ID, and the final flow execution after it connects to the database, whatever the database output is, it has captured that as well. So all of them are already recorded. So now what I want to do, I told you, right, when connecting to the database or connecting to any external HTTP call, all of them should be mocked out so that you don't have any external dependency. So what I will do, I'll go ahead and mock this processor. So all I need to do is select mock. If I didn't use the test recorder, I will have to use the MUnit test tool separately and create a test case and then create a mock and then configure the mock and do all that. But here, all I do is select mock over here. So I give next, and now I see a summary I will see in the test case, and I just give finish. That's it. What it has done now is, if you come here in source test resources, it has created a separate folder. If you see here, a separate folder for this test case. It has created a separate test case, and in that it has mocked that select the thing with the database select, right? It has mocked that processor. If I didn't use this, then then I should have done all of this from the scratch. I should go to the Mule palette. I should use MUnit tools. I have to use all these Mule operations like mock, assertion, fly, spy, all these things I have to use, and I have to do this one by one. But now it has already created the mock for me. It has set the input for this. And if you look at the input, for example, see what it does. So this test case requires an input to execute, right? So it requires an input for the test case to be executed. So where does that input sit? If you go here, it is reading it from a data.v file. So it is doing a read URL and is reading it from a data.v file, set event payload.data.v. So if you come here and if you see set event payload, this file, this is where it's reading. And remember, we didn't pass any payload. Our body was empty. We're only passing the URI parameter for this particular Mule application. So the URI parameters will be in the event attributes. And if you see here, you have the URI parameters, account ID 16. So it has captured all the URI parameters, all the headers. It has created data.v files for readability purpose, and it has already created a separate folder, and all the data.v files are stored over there. So it is referring to those data.v files when it sets the input event. And so in this payload, nothing will be there. So we don't need any payload. And if you go to attributes, it reads the set event attributes, which is there in this file, and it will set the event attribute, will set the customer ID as 16. So the input is set, the mock is done. So it will execute the flow, and it will finally do the assertion. And if you see here, it is using assert expression. Remember, I told you there are 3 types of assert, right? Assert that, assert expression, and assert equals. So assert that will use inbuilt data.v function, but assert expression, which is what the MUnit test recorder has generated, will use separate data.v files to do the assertion. So if you see assert expression, it has a separate data.v file where it is doing the assertion. It is checking that the payload is equal to whatever the database output is. So whatever you retrieve for account ID 16, the database output is there, and it is checking that the payload is equal to that. So it is doing that assertion in a data.v file. So it has already created the data.v file. This is good actually for readability purpose, for maintainability. Should have your assertions in separate data.v files. It's recommended. So test recorder is automatically doing that, and it is using that data.v file to do the assertion. It's reading the data.v file here and doing the assertion here. So the example of assert expression. So that's it. I created a test case for one flow in like a couple of minutes. Now let me create a test case for the main flow. I want to show you mock, spy, and everything, right? So again, what I will do, I'll go here, I'll do record test for this flow. it will again launch the embedded Mule runtime. Okay, so again I have to invoke the flow now. So again I invoke the flow. Again it does the recording, and now I can configure the test. So it's the same test suite name, but it is another test case. This is a test case for the main flow. So it's MUnit demo flow, that's the main flow. And if you see here, now let me do, okay, I have a transformation, right? I told you one of the use cases for SPY is transforming the payload. So I select on SPY, I select transformation message. So what it will do, it will SPY before the transformation and after the transformation. So it will automatically create, I'll show you, it will create a SPY on this transform message component, and it will have assertions to check the value of the payload before and after the transformation. So I selected SPY on this, and then let me also do a verify call. So take this flow is what we just created a test case for, right? And it connects to the database and this thing. So I want to make sure that flow is executed only once. So I click on verify that, and I check that this step should run exactly one time. So I do that verify call, and I'll also do a mock of this thing. So basically, you can mock external dependencies. You can also mock internal flow references if you want. I mean, try in order to do that, but I'm just showing you for example purpose. You can also mock the flow reference call to the third flow. So I'm mocking that as well. So I have a SPY, I have a mock, I have a verify call. So when I do a next, these are all what I will see in my test case. And I click on finish. You see here, so this was the first one we created, and if you see the second one, it has already created all of this. Now, if you were to do this from the scratch, it will at least take you. I mean, you need some this thing, right? You need to configure each and everything separately. So this is the, if you look at here, this is the SPY. So it has spied on the transform message. It says what it is spying, and it has assertions before and after. Both these assertions, this is asserting before the transform message, and this is asserting after the transform message. Similarly, you have the verify call. How many times the particular flow was called, that check is also there. And you have the mock as well. I told you I'm mocking the flow reference, right? So I've done that as well. So that's it. As simple as that, creating the test case, as simple as that. And I have one more test case, right? I'll create for that as well. And I will show you negative test case creation for this. So what I'll do, let me create a test case for this as well. This is the third flow which connects to Salesforce to create the record with the details fetched from the database. So I'm creating a test case for this flow as well. Invoking the same flow, it will do the recording, and then it will let me configure the test. So I'll quickly do a mock. I'm connecting to the Salesforce, right? So I don't want to connect to any external dependency. So I'm again mocking out that external dependency. I'm mocking out that Salesforce call, and I'll click on finish. So now I have in my test suite, I have 3 test cases. For each test case, I have 3 folders over here. If you see, I have 3 different folders automatically created. Each of those folders have the data files which are used within the test case. So so if you take one test case, the SPY, the assertion, the mock, all of them, whatever they do is already documented in this data file and created as a separate data file in a separate folder for you. So you have 3 separate folders created automatically. You have 3 test cases created. And so this was the first one for the database call. This is the main flow where we created mock, SPY, verify call, everything. And this is the third flow which connects to Salesforce. Now, when you take this flow, I wanted to use this as an example for negative test case. So if you go back here, right, I have a on error continue to, in case I connect to Salesforce and I have a connectivity issue, I'm handling it in a on error continue, and I'm setting a custom error message. So how will you ensure that flow is tested? So that error scenario cannot be automatically created using MUnit test recorder. So if you saw, I just did a mock and created a happy path, right? So if you want to do the negative test case and create a test case to check that if it goes to the error handling logic to make sure the error handling logic is properly executed or not, we'll have to do some configurations. Like when you come here, when you click on mock, you have, like, if you see here, you have the payload, right? This is the happy path. So basically, it is mocking the output from Salesforce. It has it in a data file. So if you go here to the mock payload, this is the output from the Salesforce. after the record is created, you have this is the output from Salesforce. So it has it in the data v file and it is doing that success path. But I don't want that. This is a negative test case. So what I will do, I will, so I want to mock this error, this Salesforce connectivity error. I'm going to mock that error itself. I'm going to induce that error. So what I'll do, I'll just copy that. I'll go here and in the mock, instead of mocking the success scenario, I will change this. And you have the error field. So you can actually mock the type of error that you need. So I've introduced now, when this test case is executed, it won't do the happy path. It will actually mock this error, and then the flow will be called. So the flow should execute as if this error happened, and the error handling logic will be executed. So you will know if the error handling logic is successfully executed or not. Okay. And what I will do, I also have to check that after the error handling logic is executed, I have to check if the final custom error message is what is set within the error handling logic, right? So I will do that using assert that. So what I'll do, I'll remove this assert expression. I don't want assert expression, and I'll go and use this assert that, because I wanted to show you an example of the inbuilt data v functions, right? So here what I will do, I'm just checking that. So I mocked the error, the flow is executed. Now I'm checking that the final payload is equal to, this is the data inbuilt data v function I told you, the MUnit matches, right? So you have to use MUnit tools, this syntax, and when you do control space, you get a list of MUnit inbuilt functions. So these are the inbuilt functions I told about. And you only if you use assert that, you can use these inbuilt functions. So I'm using this, and I want to do a string comparison. So I'll do a equals to ignore case, and I'll just do a string comparison. So I'll take this value. And I'll just make sure that the final payload value is equal to that. So basically, I've created a negative test case now. I've induced the error, the Salesforce connectivity error. I've triggered the flow, and I'm checking that the error handling logic executed, and the final error is what. This is a negative test case, right? It's inducing an error. So now I have 3 test cases in the test suite. So I'll just go ahead and run the test suite. I'm running it from Studio. So if you see here, all the 3 test cases got executed. All of them were successful because they're green. And you can also click on this generate report to see what is the application coverage. So there's 91% application coverage. So if you go here, you will see what are all these components were covered as part of the test case. I just created negative case for this, right? So this I induced the error and the flow was executed, so it would have gone to the error handling logic. So this portion was not executed, so it's 91%. But automatically all of that is generated for you. Now, if I want to execute the same test cases from my CI/CD pipeline, so I would have configured whether you're using Azure DevOps or you're using Jenkins, whatever it is, you'll create those pipelines, and then you will execute the commands, the Maven commands, right? So whenever somebody does a check-in of their code, immediately you should have these test cases executed. And I'll just show you simple from the terminal. If I'm executing the test cases, all I need to do is I go to the project folder, the MUnit project folder, and I just do a Maven clean verify. Sorry. So again, that will execute, it will look for all the test cases, it will execute the test cases, and it will give the final test report. You can write it to any file, and and this is where that configurations will all come into play. The pom.xml configurations that we saw, right, within the plugin. So all these configurations will come into effect when you execute it using Maven. So now I had given, if you see format is console, right? So that's why you will see the final test report as a console output. You will see over here. It will come now. It has just executed the test, and you will see that. So you can control all of that. So if you see here, you have this MUnit coverage report and this entire thing, right? The application coverage, 3 of them were successful. So this came because I did the configuration over here. So you can do much more configuration. When you run your Maven commands, like I did Maven clean verify, you can pass you can pass other parameters. If you want only specific flows, specific test cases to run, you can pass that. If you want to skip certain tests, you can do that. If you want to, categorize your test cases. So you can specify, you have tags over here, so you can categorize this test case as a positive test case or a negative test case, and you can pass the tag as a parameter when you execute your maven command. So only those positive test cases will be executed. So you can do all of that using those this configuration, the maven configuration. So that's it. And then you can, of course, generate the report in whatever. If you go here, if you just refresh it, you should see in the target reports section, you'll have all the reports generated. Whatever whatever compatibility you need, you'll have reports generated. You have Surefire reports, you have XML reports, JSON reports. So whatever reports you need, it will be generated, the final report. So that's how easy it is. So it took me hardly 20 minutes to create a test case for I know it's a simple application, but this test recorder is still evolving. It's not going to satisfy. It has its own limitations. Like if your flows are returning errors, then it will not be able to create test cases. Because you saw, right? If I wanted to create an error flow, I couldn't do it automatically on test recorder. I had to do configuration changes for that. Similarly, if you're using a for each and you want to mock a message, if you want to mock the message for every iteration of the for each, if you want to pass a new message, you cannot do that. All these complex scenarios won't be handled by the test recorder, but for your straightforward cases, test recorder is more than it can easily speed up your test case creation time, and you can easily create. You create test cases just like I did within minutes and have it executed automatically. So I hope you could follow, and the screen was okay. But that's the demo I wanted to show. Simple execution of test recorder, how we can use the test recorder.